time is really gone, so I would really request the presenters to make it short. If you can do it in 7 minutes, that will really help us a lot. Okay, I'm Joyce Lele Ndemo, and then my rapporteur is Dr. Morris Oyo. We are both from the same department. So we would like to listen to our keynote address by Professor Ogendo. I wish to introduce him. Professor Ogendo is an associate professor of crop protection, as well as the principal of Nakuru City Campus here in Egerton University. He's also the president of the International Society for Pesticidal Plants. He holds a PhD in crop protection, an MSc in agronomy, MSc in grain storage management, and a BSc in agriculture. Professor Ogendo has served in various positions in the university. Currently, he is the director of CMRT project from 2019. He has also served as the dean of the Faculty of Agriculture for 4 years, from 2014 to 2018. He has also been the chairman of the Department of Crops, Horticulture and Soils for 5 years, from 2009 to 2014. He is also very much experienced in research, especially participatory research, community outreach, consultancy services that focus mainly on biointensive pest management, which is his field of specialization. He has also worked with, on underutilized crops and livelihoods in smallholder agriculture. He has also done quite a bit of research projects as principal investigator for up to 18 projects, and also collaborated in different research amounting to 25. And this has garnered a lot of funding, up to a tune of 2.15 billion. Professor Ogendo also oversaw the signing of MOUs with international institutions such as Virginia Tech, Zhejiang University, China, Natural Resources Institute in the UK, FAMU in the USA, Bowie State University in the USA, also many others that I may not be able to say, but we appreciate that he has been involved in bringing linkages between Egerton and other universities, which is also a core mandate of the university. We also note that Professor Ogendo is a prolific scholar with 53 publications in referred scientific journals, 4 book chapters. He also has a patent application. He is a member of professional bodies and working groups, member of the ESC Research and Development Working Group. He has also successfully supervised many MSc and PhD students. And also he has contributed to human capital development in Kenya by training postgraduate students. So he has a wealth of experience, and I'm sure, I have no doubt, we are going to benefit a lot from his keynote address, which will be learning points for all of us, be young or senior researchers. So with that introduction, it is my honor and pleasure to welcome Professor Joshua Ogendo to give us his keynote address. Welcome, Prof.
Good afternoon, ladies and gentlemen. Unfortunately, the chair has talked of 7 minutes. You cannot deliver a keynote speech in 7 minutes. I don't know whether that was also applying to me. Now, when I was asked by the Division of Research and Extension to throw myself into the ring, I decided to pick what is likely to resonate with what is happening today. And my topic is unlocking the global food crisis, a case of biotechnology and climate-smart solutions for sustainable and healthier food systems. I've requested specifically the gentleman from NBA to sit in, because aspects of what I'm going to talk about could border on issues about technology, but with GMO in mind. So if there are questions relating if there are issues relating to GMO directly, you will be able to answer them. But me, I would want to put much more genetic engineering aspects which border on gene editing and which are not classified as GMO. Maybe we disconnect just 1 minute to disconnect this, because I think that is what is confusing it. So whatever I'm going to present is going to pick elements of biotechnology and climate-smart solutions that I would believe is of interest to this particular forum, and maybe moving forward should be able to help people recast their thinking. Now, those are some of the major items that will go into this presentation, and you can see basically GMO is not part of it. Now, I'll look at, give you a background and look at the global scenario with respect to challenges that actually affect our food systems. Now, by 2050, as we are talking today, no, it's okay. Okay. It is you to share. Me, I've already done. So, okay. So globally, by 2050, we expect the human population to hit the 9.3 billion. And a host of challenges that actually afflict the globe with respect to food systems range from climate change to including disasters like the COVID that we had. But if you look at this graph on the left, the growth rate for the population has been declining globally. And I think that should be good news to all of us. But when we look at the next slide, you should get worried, because in as much as there is decline in the rate of population growth, the global rate is lower than what we have. Africa is holding the highest rate, which is at 2.37%. And you know that one, basically it means the entire globe, we are the ones who are contributing the biggest, making the biggest contribution to humanity as the population continues to swell. Now, something of interest in the background is the distribution of food shortage in the world. And you should be able to locate where Africa is. And if you look at the colors that are shaded from brown to very red, you're talking about from medium to extremely risky scenario in terms of food shortage. Now, so where do we, as Africans, find ourselves? We find that Africa, over 80% of Africa faces medium to extreme risk of food shortage. And the latest, February 2024, 45 countries need external food aid. And out of the 45, 33 are in Africa. So you see why we need to think as and when we need to think of interventions. Now, the World Food Program, again, just this month, in their statistics, 50 million people are actually food insecure in Eastern Africa, not East Africa, but Eastern Africa. And out of those, 3 countries have been highlighted, with Sudan having about 17.7 million. You've got Ethiopia at 15.8, and then South Sudan at 5.6. 7 million people who are actually facing food shortage. Now, when you look at the global food demand, for the world to feed itself, we need to produce 60% more food to be able to feed the population of the world by the year 2050. But interestingly, the demand for the protein-based foods is increasing and is at a higher rate, level. We need to increase by about 85%. So the food situation that globally is going to worsen with the time as we approach the 2050 unless drastic measures are taken. Now, the big dollar question that we need to ask ourselves, can agricultural productivity gains keep pace with the population growth sustainably? Because we could be doing knee-jerk attempts to address the gap, but can we go for a sustainable strategy that makes it work for? Now, at this point in time, I would want us to look at food systems versus sustainable food systems. Now, with respect to food systems, we are just talking about that process that encompasses the range of actors and their interconnectedness, value-adding activities which range from production, consumption, and even post-production. But when you talk about sustainable food systems, now you're talking about, it's a food system. Already you have got a food system, runs from production to consumption, but it has got 3 stones holding it. One, it is a system that delivers food and nutrition security in such a way that that process is economically sustainable, which means it's profitable. It has got broad-based benefits to society, and at the bottom line also, it has got environmental benefits, which means it's environmental sustainability. Now, FAO has come with the two concepts. To the left is just the food systems wheel, and which focuses at the center on 2 things: poverty reduction and food and nutrition security. But the same FAO proceeds to give you sustainable food systems, but one where that sustainable food system is the intersection of the 3 major impacts. The impact of the economics, the impact of the environment, and the impact of social. And therefore, sustainability is in place. So it proceeds to tell you that sustainability is a function of a healthy environment, is a function of economic profitability, and also a function of social equity. Now, in terms of some of the scenarios that we have at the moment, we must recognize the interconnectedness of our actions with the health of our planet. We are sitting on a planet, and it is our responsibility to make sure that that planet is healthy. Now, the current food systems, while capable of feeding the billions we are talking about, often come at a significant cost to the environment. 3 major costs are highlighted: deforestation, greenhouse gas emissions, and soil degradation, just to mention a few. But what we need to recognize that a few consequences of the sustainable agricultural practices actually chart the kind of scenario that we have at the moment. Now, to assure that health and prosperity of future generations are catered for, we must transition towards more sustainable agricultural practices. Now, what we have in this slide is what was explained in the FAO 2014 SFF, the Sustainable Food Systems, where you have got the economic, that is commercial variability, you have got the social equity in distribution of the economic value, and then finally the environmental. Now, to achieve agricultural sustainability, there is a need to strike a balance between economic viability, environmental stewardship, and social responsibility. Now, there is a model that I came across, which is an interesting model that I think as a university is a challenge, and it's a model that is actually embraced by Washington State University, and it partners with farming communities, and in that partnership, at the center of the partnership is Food Systems Hub. And this hub has got 8 important elements that make it work. Amongst those elements is food production and processing, food business distribution, and it ends up with a very critical component is food safety and public health. Now, in the things that we do, ask yourself, and I know there was a question about safety of the products that are released into the market, including the GMO. Are we prepared, and are we working with the farming communities in a model that can actually mirror a scenario like this and make the impact? Now, hence, to assure sustainable and safe food systems, we must make deliberate efforts to define key elements or components of the sustainable food systems that includes food safety and public health. Now, the role of agricultural biotechnology in sustainable and safe food systems. And I know we have Naima in the room. He would be the guru if there are questions bordering on GMO, I'd say. But agricultural biotechnology is indicated to have great potential of providing solutions to major challenges in creating sustainable agriculture. And an example in mind, there is growing enough food in provided limited space as we continue losing the amount of land that you need. With limited resources, under different environmental stress, actually, those are the things that you expect biotechnology to help you bridge. In which case, you will not require a lot of land. I know some people are holding thousands and thousands, yet they are producing what would be equivalent to what somebody who's holding only 1 acre. Now, personally, I vote for gene-edited crops and microbes, but for GMOs, somebody else will answer that one. Now, when you use gene-edited crops and microbes, they have got the potential to lower the pesticide use. He talked about agrochemicals, soil damage by cultivating disease-resistant or herbicide-resistant crops, but it also helps you increase the nutritional quality of the plants. You are able to also reduce significantly the greenhouse gas emissions and also fertilizer use. And with respect to fertilizer use, anyway, the highlighter is not picking. The last bullet point is talking about pivot bio-N microbes, which are being used in cereals, and I think the mayor could be aware about this one. I was part of this process. It's a product, a microbe that has got the capacity to actually make a cereal fix nitrogen. And the target in this country, it has targeted maize. The field efficacy trials went out successfully. NBA gave it a green light because it was not classified as GMO because it was gene-edited microorganisms through genetic engineering. But now the product is at the process of validation on farm now, because it has been registered in Kenya, but now the company, which is an American company, is trying now to see if it can be validated on farm. Now, when you talk about biotechnology, and you take agricultural biotechnology at the center, there are a lot of benefits that you can generate using biotechnology. The outer layer gives you the overall, what you call the overall outcome, the impact it has in society. Agricultural biotechnology can actually ensure that you have got food and nutrition security. It can ensure that you actually conserve your land, can reduce the waste, reduce the emissions, can also lead to water preservation and carbon sequestration. Now, through about 2 dozen agricultural biotechnology products such as the disease-free plants and so forth, you can be able to conquer the world and address issues relating to the food crisis that we have. Now, the notable gains that we can pick from the agricultural biotechnology, one is crop adaptation to climate extremes, and that one I've talked about. The second one is increasing yields of agricultural intensification, in which case you are talking about high-yielding varieties developed through biotechnology. For example, the golden rice. I know ladies like rice. Ama hiyo nimesema uongo. See, they like rice, but it is indicated the golden rice gives you, it's a genetically modified material, but not GMO, which has got enhanced genes from daffodils and a bacterium for production of provitamin A. And provitamin A has got beta carotene, and you know what it does in the human body. Eh? So those are some of the benefits you gain when you go biotech. Now, biotech can also help you tackle food loss and waste. And this is through genetic engineering. You go for traits that keep produce, like fresh tomatoes can keep longer. It can also help you increase blue foods production. And when we talk of blue food, we are talking about the water resources. Like, I know people like fish. And it can help you genetically engineer fish. For example, genetically engineered salmon is known to gain weight faster, in which case you can go for fish farming and you make your money. But at the same time, you are helping society address food and nutrition security. Now, livestock with resilience to drastic changes in climate is also something that you expect to get from biotechnology. For example, heat-tolerant Angus cattle, and I know I'm happy that Professor Baby is in this room. If there is a question about Angus cattle, he should be able to answer that one. Then there is greater use of conservation technology, which actually leads to improved waterways and soil erosion. Now, some of the genetically engineered products which are already in Kenya, and I know Nehemiah can talk about them, I've just picked a few examples. The BT cotton is already released. But insect-resistant and drought-tolerant maize were ready for release. But because of the court injunction, whatever, it is still being they are holding on to it, but it's actually ready for release. Then there is what you call the CBSD, that is cassava brown streak disease resistant cassava. This is at an advanced stage of release, and I believe by now it should be ready, just awaiting that hurdle of the court case to be over.
They are doing national performance trial.
Yeah, but they're very close. The last one, yeah. Now, climate smart solutions that we need to think about. I just picked something to give you an pictorial impression of all the things that climate smart agriculture solutions can offer. Now, if you go for conservation agriculture and in a mechanized approach, you can actually reduce the impact that you have on the soil. But you also need some vegetation, and that's why agroforestry systems become very handy. Now, when we talk about the climate smart agricultural solutions, 5 things come into mind. You need to think about crop management technologies, which are actually climate smart. Think about livestock management technologies that are actually climate smart. Soil and water management is at the center of both those two I've talked about. In the event that you lose water, you don't have water, even the crops that you are managing, the animals you are managing may not be able to survive. But you also need to think about integrated food energy systems. And finally, agroforestry is very critical. Now, the next frontiers of science, where I would expect people to start thinking about, is environmental and ecosystem health. It's something that we don't need to wish away. You need to think about climate smart agriculture, but with respect to crop and livestock, a lot still needs to be done. Then gene editing, and which I say to me is a pet, I'm not a biotech, but it's gene editing at the end of the day, the product you have is not classified as GMO. And to me, that is a softer way to go about the process than the full blast GMO. Now, we need at this stage to interface what you call climate smart agricultural solutions with precision agriculture and artificial intelligence. It is emerging very strongly, and as a university, I would want to challenge ourselves. We are doing very badly with respect to artificial intelligence. We are being left behind. It's something that we need to pick up quickly, and if it is capacity, let us get that capacity. Even if it is building that capacity internally, we build that capacity. Now, the next thing is agro-food sector with minimal greenhouse gas emissions. And in mind, already you are aware that energy and transport is being decarbonized, in which case we are reducing the greenhouse gas emissions. Now, the concept of farm clinics and innovation labs. Concept of farm clinics and innovation labs. These sustainable food systems that we're talking about need to sit within the right frame and needs to sit well with the people who are supposed to be holding it and who are the farmers. And therefore, we need farm clinics and innovation labs where farmers are part and parcel of that process. Now, with Egerton hosting the ASGEB Regional Center, omics is the today's frontier of science. And I believe breeders and even molecular scientists are in this room. Now, in conclusion, I would want to say scientists and society must embrace and practice sustainable food systems for environmental, economic, and social sustainability. Universities should partner with farming communities in creating food systems hub, guided by the 8 pillars that is culturally relevant, safe, and healthy for all. And then finally, biotechnology and climate smart agricultural solutions hold good promise for global sustainable food systems and food and nutrition security. Thank you, ladies and gentlemen, for listening.
No, you are doing well. Okay, that was a very enriching session. We've learned a lot how to consider the economics, the environment, and the social angle in our work. And I would like now to get responses from the floor. If you have any question, any contribution, you can raise your hand and we'll be able to see you. Any contribution? Professor Bebe. Just can, I don't know if there's a microphone or.
Yes, thank you for that talk you have given. You are proposing that we find a balance between economic, social concerns, and environmental. Given the African food crisis, how do you see that working? And you are proposing that the action should be at the farmer level. So would you give how you would see that working? 2, protein you have identified as a crisis within the food, demand for it. But I also want you to respond to this response of cultured meat that is being touted as the solution to the human increasing demand for meat.
can take the next one, then he'll answer all of them together.
Thank you. I want to appreciate Prof. Presentation. Actually, the slides are up to date, especially on the biosafety part. Just to mention that we've published genome editing guidelines. They were published in 2022, and in the genome editing guidelines is that we do early consultation to check if the end product does not have any foreign GMO, or it is regulated as any other conventional crop. And I've liked that. And if the early consultation shows that the end product has some foreign gene, it will be regulated like a GMO product. So I really like that. And also, just to say that the three products that Prof presented there, the PT cotton is already with the farmers. The GMO maize, we've gone through the whole process, and we are just waiting for the case and the ruling is on the 9th of May. And it is going to be positive, because already we've won in one of the court cases in the environmental court. And the cassava will be the third one, and they are projecting, the scientist, Professor Miano, is projecting to have a full environmental release end of this year. Yeah, and we don't just approve GMO, we also reject. If we reject because of the social economic consideration issues, we've rejected one, a Gypsophila flower that was modified to be purple, and it's usually white. So it was rejected because of the social economic issues consideration, not because of the safety part. So just to concur what Professor have said, it's not a question. It's not.
Okay, maybe the last one. And then online, if there's any question online, you alert me.
Thank you so much, Professor Ogendo, for the nice presentation and quite enlightening. I have concerns, no, not really concern. I don't know what to call it, but genetic engineering, or gene editing. All these are just languages, I think, used very cunningly to mean the same thing, because at the end of the day, this organism has its gene being modified, first and foremost. Two, given a situation where, like, I want to talk about a country where its leadership sometimes even said, in one of the ways to die, one of the 1,000 ways of dying, they are just adding one more, so maybe it is 1,001. And even this court, sometimes, and we have listened to this court and this leadership, say that there are only like 3 ways. Yeah? So some of you will be taken to heaven if you do not accept these genetic modified organisms. So my question is this: are we really safe with these GMOs? Thank you very much.
Thank you, Daktari. Professor Ogendo, can you respond?
The last one is a question for Nehemiah. I will be able to answer that one. And I'll ask Professor maybe to repeat question 2. It was cultured meat.
You identified that demand for protein is an issue in the food crisis, especially Africa. Israelis and Europeans, I think Americans, have come up with cultured meat. So I was asking you.
Alternative, which means alternative meats.
Cultured from the lab and
yeah,
to meat. But is this, would be supporting what our food crisis is? Is this an answer to our problem?
Now I'll start with that one. To me, using the approach that you are talking about, especially like what is being done by the West, to solve the African scenario with respect to proteins is not the answer. We need to go for African-led solutions. And if you are aware, and you are in this country, people have already started making inroads, some of what are known to be our own initiatives which we ran away from, and we are going back to the roots. People are already working on alternative protein sources, and you are aware that even the locusts are being considered
And that is for both food and feed to address the protein. Now, the first question was about balance between economics, societal, and environmental sustainability. And if you look at my second last slide, I talked about having issues of farm clinics and what you call the labs, the innovation labs. If whatever solutions you are proposing, especially the sustainable food systems, comes from ourselves, not superimposed from elsewhere, then you work it through together and it should be able to be sustainable. Because the key thing is, if it is environmental, you are looking at the health of the planet, health of the soil, health of the person who is going to feed. So it's something that needs to be, we need to generate it together, not somebody else coming to impose. So to me, it is something possible. But the only challenge which always runs in my mind, and which I'll leave with this room, Africa, just like the rest of the third world, is facing the future with eyes closed. With eyes closed, you must be having your eyes, but you are not using them. I'll tell you why. Land, everything revolves around land. And in this country, by virtue of being born, gives you like a ticket to access land. And therefore we continue subdividing our land into units which cannot be economically viable. And that would be the threat to what the professor was asking. The last part of the question, I'll give Nehemiah to deal with that one.
Thank you, Prof. Different between GMO and genetic editing, I think, Prof, you could have said that. GMO, you have a foreign gene introduced. An example is GMO maize. They've introduced the PT, Bacillus thuringiensis. But genome editing, there is no foreign. You just deal with you are an expert in that. So what I know is that there is no foreign gene while doing genome editing. Political statement by Moses Kuria, it was unfortunate. He said GMO is part of the list of going. So what we are doing is that before we approve any product to the Kenyan market, we do thorough scientific evaluation, environmental risk assessment, and we also do food and feed safety assessment. And that's why I was saying anything that has been approved by NPA, just be sure that it has gone through a thorough risk assessment process. And we have rejected some of the applications by scientists, and we usually take concerns of the public, even the ban. When the ban was imposed in 2012 because of the concern by a publication by Professor Seralini Pepper that said GMO causes cancer. That was a big concern, and that's why there was a ban. But scientists, they usually go back to do their research. Because of the concerns of Kenyans, like my friend there, is that once there's a concern, a serious concern, the first thing is to stop. And then you go back and ask the scientist, can you go and actually see if it is causing cancer? So from 2012 up to 2022, 12 years, almost 10 years, the scientists have been doing research actually to see, does it cause cancer? And up to now, there is no evidence. And I know Professor can... what happened is that Seralini Pepper, he fed rats that they eventually grow growth, even if you don't feed it. As they grow older, they get those, and then they took a photo, and it was the paper was retracted, and it was recalled. So it was unfortunate that most countries banned the GMO because of that. But what happened, it was a caution, and for sure anything that has been approved by NBA, for us, we use substantial equivalent. It should be as safe as any other food.
Okay, thank you very much.
Thank you.
I would like to bring the session to a close. Let's appreciate Professor Ogendo for his talk. Thank you very much. Now we want to listen to different researchers. We are going to start with the first presenter. Just a minute. Can you upload for Nakiganda? ICT? You give it. Is Nakiganda logged in? ICT?
Yes, I am.
Would you please take us through your presentation as fast as you can, about 7 minutes, and then 2 minutes for questions. So welcome, Nakiganda.
Thank you very much. As mentioned, my name is Dr. Gladys Nakiganda, and I'm presenting the paper we wrote with the traditional panel and Prof. Debate on the factors influencing sustainability of incubated university agribusinesses. Among the many causes of unemployment in Kenya, is the failure to align the education curriculum with the demand of the market. Statistics reveal that the overall unemployment in Kenya is at 4.7%, with youth ranging from 15 to 34 years old, forming 35% of the Kenyan population, having the highest unemployment rate. Over 1 million young people enter the labor market annually without any skills, some having dropped out of school or completed school and not enrolled in any college. This has led to more than a third of the Kenyan youth eligible for work, leaving them with no jobs. So with the aim to create graduates who are job creators and job seekers, universities are promoting entrepreneurship incubation as a means of instilling entrepreneurship mindset and creation of business ventures among university students. In this process, business incubation process, youth with high potential to be entrepreneurs are provided with support services to develop their ideas into viable and physical businesses. However, many of these supported businesses struggle to survive beyond 3 years, and others seize the moment incubation ends. Our work considered 2 theoretical frameworks: the resource-based theory and also the triple bottom line theory. The resource-based theory was relevant because it considers the entrepreneur's cognitive abilities as a resource to their firm that can lead to their firm to attain a sustainable, a competitive advantage. While the triple bottom line approach suggests that an organization can facilitate its movement towards sustainability development with a management approach that integrates the social, environmental, and socio-economic sustainability. So to determine the sample size, we use the Cochrane's formula, and we got 272 respondents. So we used a multi-stage sampling technique where we selected 7 major universities in Kenya with incubation centers or programs that have lasted for 3 years and above. So we approached each particular administration for a university to know the incubation centers they have, and we also approached those incubation centers to get the list of the youth that have been incubated 3 years before the time we collected data. So using the simple random sampling technique, we got our final respondents. And because the study only focused on agribusinesses, we divided that every university gives the respondents, gives 39 respondents. But since it was agribusiness, some of them were not able to provide the 39 respondents, and thus we kind of maximized with universities with a bigger number. So these were the universities of University of Nairobi, Kenyatta, Riara, Strathmore, Moi, Egerton, and this is how the respondents were distributed. Yeah, we used SPSS, Stack, and Smart PLS for analysis, and the driver's motivation instrument used in the investigation had 20 composition items which were rated on a 5-scale point. So the statements were essentially statements presenting underlining student motivation to participate in university incubation programs. So either a student participates in incubation programs because they want to take advantage of incubation as a business opportunity, or a student feels like there are no better choices for work after school. We adopted this from the Global Entrepreneurship Monitor, in short, GEM. And because of that, we used this principal component analysis to investigate dimensions. And before the principal component analysis, we studied the assumptions of multivariate analysis. The retained principal components that we got from the principal component analysis, we use them in the structure equation model to determine the factors influencing the sustainability of university incubated business. This approach aimed to explain the causal relationship between research variables and the test hypothesis. So this SMART PLS, or the model, considered 3 hypotheses, which are the significant direct and indirect effects of necessity motivation factors on the economic, environmental, and social sustainability of incubated businesses. The second one was there are significant direct and indirect effects of opportunity motivation factors on the economic, environmental, and social sustainability of university incubated businesses. And the last one was there are significant effects of personality of students participating in university incubated programs on the economic, environmental, and social sustainability of their agribusinesses. Furthermore, the results from the principal component analysis gave us statistically significant results of the multivariate normality test, meaning that there was enough variance in the data that could be used that could be partitioned using the principal component analysis. All factors were above 0.4, and the oblique rotation indicated that there was no correlation among these factors. These are the components we got, as you say. The first one, which represents the necessity motivation factors, and also the second one, and their communalities. According to the findings, factor 1 represented 36% of the variance. These students were motivated by a need for employment after school and felt that there were no better options available for them. So with an alpha value of 0.823, majority of these students, majority of these students join incubations as a way of adding value to their education. This suggests that University students are driven by necessity motivation factors to participate in incubation programs. Necessity entrepreneurship refers to non-optional or enforced entrepreneurial activities when someone has no alternative due to personal reasons or certain conditions. In other words, the students feel like their education alone is not enough to guarantee them a successful career and employment after graduation. For factor 2, which accounted for 18.786 of the variance, this constraint suggests that university students' motivation to participate in program is associated with their pull factor of taking advantage of an opportunity. This shows that some students participate in incubation programs to upgrade their social status, which was also highly supported by an alpha value of 0.817. The two factors, together with personality, were put into a structural equation model. The model ascertains the significance of the hypothesized relationship between necessity motivation, opportunity motivation, personality, and stigma failure on the economic, environmental, and social sustainability of these businesses. So to start with the model, we first validated, we first measured the validity and reliability of this model before coming up with a model, and then results revealed that the composite reliability was over 0.7, while the average variance extracted was higher than 0.5. We used the heterotrait monotrait ratio discriminant to assess the discriminant validity. This was the structural equation model that we got. And according to this structural equation model, we drew hypotheses, or we came up with insights. According to the hypothesis 1, which was the significant direct and indirect effects of necessity motivation on the factors influencing the economic, environmental, and social sustainability of university incubated businesses, results revealed that yes, they are significant direct and indirect effect of necessity motivation factors on the sustainability of these businesses. The insight is students participate because they feel like they need to secure unemployment, which also affects the sustainability of their businesses. For hypothesis 2, the significant direct and indirect effects of opportunity motivation factors on the economic, environmental, and social sustainability of the university in the incubated businesses, results revealed that no, there are no significant direct and indirect effects of opportunity motivation on the sustainability of these agribusinesses. Meaning, opportunity motivation factors do not influence the sustainability of university incubated agribusinesses. The fact that someone wants to improve their status, social status, among others, does not impact the sustainability of their businesses. For hypothesis 3, the direct significant effects of personality of students participating in incubation programs on economic, environmental, and social sustainability of their agribusinesses, results revealed that yes, there are direct and indirect significant direct effects of personality on the sustainability of their businesses. The behavior and personality of the young entrepreneurs in universities significantly affect the sustainability of their businesses. To conclude, the study intended to understand the factors influencing the sustainability of youth-led incubated agribusinesses in universities of Kenya. And results from the principal component analysis demonstrated a clear distinction between necessity motivation and opportunity motivation, with a lack of correlation between the two sub-skills. Results also portrayed that more university students take the initiative to participate in university businesses because they have a need other than seeing an opportunity. Furthermore, the study identified that personality of youth who participate in incubation programs such as stigma and results reveal that factors that influence the sustainability of university-incubated agribusinesses in Kenya include personality of the youth who participate in the incubation programs, their stigma failure, and the necessity motivation factors. And these factors directly and indirectly affect each other as they influence the sustainability of university-incubated business, meaning one factor influences the other. And then, lastly, findings reveal that opportunity motivation factors do not influence the sustainability of these businesses. We therefore recommend that youth with university-incubated businesses should intensify their economic, social, and environmental practices and strategies to make sure that their agribusinesses are sustainable, and they should also consider improving their personality, as it could be a better factor influencing their agribusinesses. Also, all students should be given a chance to participate equally in these incubation programs, because neither the reason for joining nor the motivation for joining determines the sustainability performance of these agribusinesses.
Excuse me, Nakiganda.
Should also be.
Excuse me.
Yes.
I think you've gone beyond our time.
Oh, sorry.
Do you think you
but
can wrap? Can you wrap up within a second?
All right.
Yeah.
All right. Thank you. Okay. The last one is university incubation, business incubator. Despite being personal star projects, universities with such projects should consider institutionalizing them within their policies for efficient operation. And lastly, more research is needed to understand other factors influencing the sustainability of university incubated businesses, such as organization and institutional factors. Thank you.
Thank you so much. Okay, in the interest of time, maybe we can take one or two questions or comments. Okay. Sure. Okay, is Adoyo in the room? Adoyo? Is he on?
Here.
Can you upload his presentation, please? I would like to remind participants that after the 3 presentations, we shall break for lunch. So at around 1:30. So I request the next presenters to focus maybe on the objectives and then the results and the conclusions so that we move faster. So is Odoyo within?
I'll do it virtually.
Where is the presentation? Has it been
Share your
uploaded?
screen.
ICT, can you please upload?
He's sharing his screen right now. Coming up.
I'm good to go.
Just a moment.
ICT, please advise us if we should have the ones who are here physically, if there's an issue with the... Yeah. Could we have somebody who is here present?
Then we'll tell the people waiting the other side, just wait.
Nancy can proceed. Nancy. Nancy, Joe. Okay, sorry for the mix-up. Since Adoyo is online, you can just present, isn't it? Adoyo, are you within?
I'm within, Prof.
Okay, can you make your presentation take about 5 to 7 minutes, strictly?
Thank you so much. My name, as it says, is George Adoyo, and I'm going to present my work on antifungal effects of trichoderma species and barriers against rice blast fungus, Magmatope oryzae. So below are my supervisors. So I'll go through introduction, materials and method, results, discussion and conclusion, and finally I'll do the acknowledgement. Introduction of rice blast disease caused by Magmatope oryzae is a major biotic constraint occurring in most rice producing areas in the world, and it causes severe yield losses and impairing production. The pathogen infects and produces symptoms in all parts of the plant, and it's expressing itself in the form of leaf, as you can see in the picture, either panicle blast, node blast, or collar blast. And the major control measures for this particular disease, it includes the use of fungicides, and of course, resistance varieties, among others. Alternative approaches for management of this disease, such as biocontrol agents, should be exploited due to their low toxicity and lack of pathogen resistance, because the pathogen is also known to mutate so fast, and it's giving us a challenge, especially in use of fungicides. So biological controls such as rice blast fungus major relies on antagonistic mycoparasites and induction of host plant resistance. Then one of the fungi that is known to work on this is the trichoderma species, which is a key biocontrol agent of plant pathogenic fungi that is known, with potential to directly affect fungal pathogens and induce resistance in plants. Now, varnish, which is a byproduct of vermicomposting, has also exhibited potential in its application as a biocontrol agent against pests and diseases. Varnish, it has microorganisms that can suppress plant diseases through complex mechanisms like antibiotics, competition through production of massive cytophores, induce systemic resistance, as well as acquired systemic resistance, as indicated. It also, on this account, that the study was undertaken to determine the antifungal activities of these two biological control agents. So the study hypothesized that to determine antifungal effects of trichoderma and species and varnish against the fungus. So the materials first started with the materials and methods, started with the collection of the fungal stock from the blast diseased fields. So sampling was done in the field in West Kano and Busia, and we managed to get the natural disease leaves. The infected tissue were carefully packed in dry envelopes, and this tissue were taken to the laboratory for preservation and finally isolation. So the rice blast fungus was selected from the tissues by sporulation of the pathogen in a moist chamber and stripped at 2% water agar media. The spores were identified by observing lesions of the diseased rice tissue using dissecting microscope, as you can see. A single spore was picked or in a sterile wire loop and put in plates containing water agar media, and that was incubated for 7 days at a temperature of 25 degrees centigrade until germination occurred. Then when the germinating single spore was cut and transferred on petri dishes containing rice bran agar media. So this is a specific media for this so that they are able to sporulate. The fungi were then inoculated on white man pepper and cut and stored. So mostly the fungi is allowed to grow on the white man pepper, and then it is cut and stored at negative 20 degrees centigrade. So when we are performing the fungal growth inhibition, we use the above formula whereby T is equals to the pathogen radial in centimeters, and then T is the radial of the growth in centimeters on the treated plates. And then a border was used, and the trichoderma cells were picked from the periphery of the colony because those are the actually active growing areas, and the plates were 9 centimeters under aseptic condition. Inoculated petri dishes were incubated at that temperature of 25 degrees, and the temperature of the radial and the growth of M. colonies were measured after 7 days. Varnish was collected from vermicomposting structures after 14 days and diluted to 10%, and was done by streaking at the edge of the agar plate. The diameter of the M. colony was measured after inoculation according to Kunai. Then all data was analyzed using the SAS version 9.4, following proper GLM procedures, and the mean separated using Fisher significance difference. From you can see from the pictures, this is what we are able to isolate from the leaves. And then from the second picture is the actual spore that you are looking for, the single spore, you can see it. And one way that we identified is the two-septate and the translucent color of the spore. Then fungal effects of trichoderma. Okay, the total of these 6 biocontrols, that is 5 trichoderma isolates identified as B, G, S, Y, A, BRO, and that. And Varnish were tested for antifungal activities against rice blast fungus. There was no significant difference among the 6 biocontrol, but actually there was significant difference between the biocontrol and the control that was never applied on anything. And then antifungal activities of these 6 biocontrols showed distinct inhibition zones in all the incubated plates. The 4 isolates exhibited between different degrees up to 71%. So maybe this one can easily be seen from this one. Of course, you can see the control. You can see Varnish at 72, EM, SYA, BGA, SYE, and BRO. These are just initial trichoderma, and these are their percentage inhibitions. Then grammatically from the photos, this is what you took, and actually you can see on one page we have the control where it has nothing, but the other one where different biocontrols were used, and this is where we got our inhibition percentage. Then the findings reveals that trichoderma, EMB isolate, and rice straw vermiwash exhibited potential of inhibiting the growth of rice blast fungus under laboratory conditions. These findings were in agreement with other studies conducted on vermiwash, indicating that the presence of beneficial microbiota boosts plant growth through production of enzymes, hormones that indirectly suppress plant diseases and other pests. Other literature studies have also shown that the effect of vermiwash on common fungal and bacterial pathogens were also seen. Then 2 bacterial isolates from vermiwash identified the Bacillus species and Biennial species exhibited significant zone of inhibition against fungal phytopathogens like Fusarium solani, brinjal, solani in tomato, isolated from seeds, leaves, seeds of various plants. Then in conclusion, the study demonstrated the potential of rice straw vermiwash and EM trichoderma isolates to have antifungal activity against the M. pathogen. Vermiwash can easily be obtained by farmers due to low cost and a byproduct of decomposition of organic matter that is environmentally friendly as compared to other synthetic fungicides. Remember, I obtained these who are farmers who are trained and are now producing vermiwash for their own. However, further research is recommended for efficacy against M. and a field condition. And at the same time, I wish to bring to your attention that I'm also working on this And maybe the results that I'll get will also be one of the output during my thesis presentation. Then I also wish to acknowledge my supervisor, Professor Paul Kimuto, Dr. Charid Miriam, Dr. Mungera, Kilimo Trust Project County Director, Dr. Mugambi, because this is where I got my vermi wash and the farmers who are already producing this. Carlo for having supported me, the farmers and my family. Lastly, thank you.
Thank you, Adoyo. I want to invite Njogo to come and present.
So as we will be leaving, you pick your milk and just at the door here for lunch on the chair.
I will have to advise them when to pick. So. Good afternoon, everyone. My name is Nancy Jogu, a PhD student working on fall armyworm at Egerton University, and my supervisors are Professor Alice Kamau, Professor Kimuto, and Dr. Eric Manyasa. So as my title, it's supposed to read screening for osteoplantal resistance for fall armyworm on sorghum genotypes. I'm sorry, it's not very visible. So that is the outline of my presentation, and it's about screening for resistance for sorghum genotypes against fall armyworm. And when we talk about sorghum, we first appreciate it as a food security crop and also appreciate its ability to resist in drought and other abiotic stressors. But despite all this potential for sorghum, we have biotic factors such as pests and diseases which are affecting the pest, which is affecting the crop, and particularly the fall armyworm, which is a new pest which came about in Africa in 2016 and in Kenya in 2017. So what happens is that a lot of pesticide has been used, leading to a lot of environmental concern, and we feel like if we could go to using resistant sorghum genotypes, we could be a bit safer. So in my case, I'm screening 16 sorghum genotypes, and this is part of my correction of 49, which I've done in the field, and I felt like they were doing very well in the field, and I wanted to test the resistance in the greenhouse. Now in the greenhouse, it's about bringing in plant materials and feeding to the insect to see how it affects their growth, that is the larval development, and also the emergence of the adult. I have a problem that my the screens are not moving. Yeah? Okay, sour. They are not moving. So, ICT, please. So that is the fall armyworm. It's a Lepidoptera, and it goes through the stages from egg, larvae, pupa, and then up to adult. And the larval stage is the one which is very dangerous to the crops.
The larval stage has got 6 stages, stage 1 up to stage 6, and it is one which is affecting most of the cereals, more so sorghum, rice, and maize, particularly maize. But the funny thing is that the pest can survive on over 80 species of crops. So when they affect maize, that is what we have on the left side is a young seedling of maize, a very serious stage for attack where you won't have any further growth. And they can also affect later stages, that is the panicle. So my statement of the problem, I've said that the pest is there. A lot of insecticide has been used by most government. It's very expensive, but leading to a lot of environmental pollution. So our study is to focus on the host plant resistance. So for my experiment, I did it in Egerton University and also Carlo. Egerton, I used the animal biotechnology lamp to rear the insect, and I raised my test genotypes at Kalonjoro. And the experiment was laid in completely randomized design, and those are my 16 genotypes. These are 16 genotypes out of 49 genotypes which are done in the field in Coimbatec and in Kiboko. That is in another experiment, another objective. And rearing the insect was very easy. I realized I could just do it in the greenhouse. It's very simple. I just went out to the field and got eggs which had been laid in batches, and I incubated them in glass vials and fed them onto the sorghum genotypes to get the larvae. And then I placed the larvae in after feeding the larvae up to the pupation stage, I was able to incubate it in oviposition cages, and I got the adult, which was supposed to lay the eggs. So the last photo is oviposition cage, which was used for laying the eggs. That is how I raised my test genotypes at Carlo, the 16 genotypes, to get the plants to test. So that is Kalonjolo. And I realized that I had to use leaf disc for sorghum. Follow-arm is a pest that prefers to feed at night, and it doesn't expose itself. So I had to allow my plants to grow up to 35 days so that I could get enough portions for the follow-arm worm to feed. And I fed them, and I was able to check how many survived, and also the larval weight, and also from the larval weight, the ones which were able to pupate, and then from pupation, I had to check the ones which were able to emerge into the adult. So what there is that the resistant genotypes normally affect the growth of the host plant. That is why I was focusing on these traits, and I used them for screening. So I did my data analysis using the SAS procedure, and there was a variation for all the tested traits except the survival, where there was no genotypic difference. The larval weight, pupation, and even the adult emergence, there was significant difference. So that is how some of my selected genotypes behaved. So this is out of the 16. What is on the left side is a susceptible check, which is Kalimutama 1, which is very sweet. It's a white variety, which is very susceptible to the fall armyworm. You can see that it has very high level survival and also high level weight. And that means that it is very susceptible. But what you have on the far right means that the genotypes could be resistant because they are not supporting the growth of the insect. That is the mode of test. So I also tried to correlate I did some correlation coefficient between larval weight, pupation, and adult emergence, and there was positive and a significant correlation between pupation, adult emergence, and larval weight. And adult emergence significantly correlated with pupation and larval survival. And pupation rate also positively correlated with the larval weight. So that is my correlation coefficient table So for the discussion, now that there was significant genotypic variation for all the traits, it means that the different sorghum genotypes are influencing the growth of the insect directly, meaning that there could be some resistance. It was notably realized there was low larval weights for these genotypes, GBK 00446, IS, that is Eclisat, line 21055, all the way up to IESV, that is Eclisat varieties, meaning that there could be some resistance for these genotypes. It was also noted that the larval weights for these genotypes ranged between 0.015 to 0.0036, which is notably far much lower than what had been learned on artificial diet for another researcher, which is 0.06 to 0.07. And we feel like the resistant genotypes possess some morphophysiological components like it has been discussed by Dillon. And this is what hinders development and therefore the low weight. So for conclusion, we can say that these genotypes, which consistently handle low larval weight, pupation, and adult emergency, could be resistant to the fall armyworm and fall armyworm in sorghum, and they could be recommended for breeding program. The positive and significant correlation between larval weight and pupation, pupa weight, pupa emergence, and larval survival probably shows that these are important traits which can be used to screen for sorghum genotypes for susceptibility and resistance. Otherwise, I am still recommending for more studies on morphophysical properties and to validate the resistance to foul and increase productivity in these sorghum genotypes. So I'm acknowledging CISAM for funding the research, and also my authors and my supervisors, Egerton and Eclisat, for supporting me. Thank you.
Thank you, Njogu, and the other presenters. I'm sure you have questions for them. I will take very few questions or comments for the three presenters, either online or on the floor. So please just raise your hand and we'll be able to bring the microphone to you. Okay, again, Professor Ogendo, and then.
Mine is a simple one to Nancy. Given that fall armyworm is a major pest and actually is affecting food security directly, now what is the timeline you have to help us start celebrating that you have got something that is likely to revolutionize the management of fall armyworm?
Thank you, Prof. Yes, please.
Thanks, Chair, for this chance. And thanks for the presenters. My name is Duncan. I have a question to the second presenter, Adoye et al. He pointed out that he isolated 5 isolates of trichoderma. Were these extracts or compounds? And if they were compounds, were they new compounds, or they were novel compounds, or they were already existing compounds? Thank you.
Thank you. I'm Afura from CA. Hello. I want to ask, first of all, goes to Adoyo. The first one is about the vermiwash. What are the specific microorganisms that are there in the vermiwash? Are they fungal? Are they bacterial? So that they will be able to take part in the as mode of biocontrol. Then secondly, on Adoyo, how did you confirm the isolated pathogen? So that you could say this is the blast pathogen, not SMART. Then thirdly, was there any compatibility between the trichoderma and vermiwash. And then lastly, that one I forgot. This one goes to Nancy, the last one. Do you have the positive and negative controls in your experiment? Then, did you manage to get any resistant variety in that particular experiment? Because there data shows that all of them were able to be attacked. But then, in the long run, you come and tell us that these particular varieties were resistant. Thank you.
Okay, I have a question to Adoyo. I wanted to know if you are, because you talk about sporulation of the trichoderma isolates, how did you measure that sporulation? And was there any difference among all the isolates that you are able to collect? And then the last one goes to Njogu, Nancy. You said that for the adult plant, you are able to test, I think there were 40-something genotypes. What informed you to choose only 16 for your greenhouse, that one for detached leaf essay? So why did you have to only take 16 and not all the ones that you use for adult resistant in the field? Thank you.
Okay, because of time, please just excuse me.
The last one, just for Nakiganda.
Do you think you can put it on the yellow?
Yes, I will do that. But the first presenter has not been asked a question. I have one. She had only two principal components, both explaining a combined variance of about 55%. How adequate is this model? Thank you.
Okay. You'll just have to bear with me, but I'll ask each presenter to answer one question, and then the rest, they can write the answers maybe on the chat or on the yellow. Because of time, because there's a change of plan again. So can we have Njogu? Is she in? Just come here, and since you're here, just pick one question that you can answer.
Okay, good afternoon once again. Okay, maybe I can talk about the first one, the timeline for management for fall armor, and I can assure you that within this year I'll have done my work and contribute to the management of fall armor. And my 16 genotypes are the ones which did very well in the field. And this is additive resistance. When we talk about yield, the insect damage, meaning that it's not complete resistance. It is additive. So it is I can say that I got some tolerance from that graph. Thank you.
Okay, thank you. Adoyo, are you still online?
Yes, I'm there. I would wish to answer one question that is almost combining the two. One was on sporulation of trichoderma. It was actually not sporulation of trichoderma, but it was sporulation of the blast of the blast fungus itself, the Magnetope oryzae. So, and again, Doc asked if I was able to specify, or how did I know that it was actually Magnetope oryzae. And as I was giving my presentation, there was morphological confirmation, and that one was also done because even the media that we were using was specific to that particular pathogen. Thank you.
Thank you, Adoyo. Nakiganda, are you online?
Yes, I am.
Please respond.
I didn't hear the question quite well. I don't understand what he was asking about the two principal components.
The model. Can you talk more about the model?
Okay.
Was it adequate?
Was it?
Adequate.
Yeah, the model was adequate. When you follow up with principal component analysis, at first you might get, the first model might tend to not be reliable because it would have factors that are crossing over, like that are like factor readings that are crossing over. But when we did we reanalyzed again, and then we had to remove some factors depending considering Hay et al. 2026, the ones he gives for the principal component analysis. So with that, we were able to end up with the two principal components that we attained.
Thank you.
Okay, thank you.
Okay, participants, I'm sorry that we are changing the lunch a bit. We have been advised to take a few more presentations, and then we break for lunch, and those who want to leave, they can leave. So please bear with us. We realize the time is constraining a bit. So we'll go to the next presenter. We'll take like 3 or 4, and maybe in 30 minutes we'll be done. So is the next one called Kunya? Is he in? Unfortunately,
yeah.
You are in.
I'm online.
What about Ouma? Please, can you load for Kunya as the lady comes? Ouma, just come and make your presentation. ICT, please. Waiting for them to load for you. Okay. Good afternoon. So my name is Ouma Mary, and together with the other 2 authors, we wrote this paper. And I was working on the effect of treatment of Prosopis juliflora, leaves and pods treated with Udash and bentonite on feed intake, milk production, and composition in dairy goats. So with the current climate change, we ought to have an alternative to the feed shortages. And Prosopis juliflora is a good alternative since it is not only nutritious, having more than 21% CP in leaves and 14% in the pods. And apart from that, it is also drought resistant, and it's evergreen throughout the year, and can survive with rainfall of as low as 50 millimeters per annum. However, it has high anti-nutritional factors. That's why I used Udash and bentonite to treat Prosopis juliflora for better performance.
And wood ash was used because it is readily available. More than 90% of Kenyans either use charcoal or wood for cooking, hence it is easily accessible. Bentonite is also accessible. It is found in along river banks and in many counties in the country. So after an in vitro digestibility test, this is the Prosopis juliflora, the leaves and pods, the wood ash, and then the bentonite clay. So the study was done here at Turton Agricultural Park, and the mature leaves and pods were collected from Marigat sub-county in Baringo County. So I used Toggenburg dairy goats, given 14 days adaptation period and 90 days data collection. So these were my dietary treatments, and the basal diet was Rhodes grass. So they were used as shown below. So the ratio combination was decided upon after a digestibility test that I did prior to this experiment, as shown. So data analysis was carried out using SAS. Yeah, three-way analysis of variance of SAS. The means was separated using Tukey at P 0.05 level of significance. So these were the results. The control, I didn't use any treatment. So we have wood ash treated, bentonite treated, and wood ash and bentonite treated. So wood ash and bentonite were used at the ratio of 50 to 50. This is because after doing the digestibility test, I found that wood ash and bentonite, when combined at that ratio, they're more digestible. So that's why I used that ratio. So the results showed that wood ash treated Prosopis juliflora leaves and pods had a higher intake compared to the rest. And then there was no difference between wood ash, bentonite, and wood ash and bentonite treated in terms of milk production. So in terms of the milk quality, these components, we can see that the untreated treatment did not perform as well as the treated treatments. So in terms of mineral composition, I just sampled a few minerals and analyzed the milk on the same, and we can see that the trend is occurring in minerals as well, with the second treatment too, which was bentonite treated, having higher iron concentration, calcium, the same, and zinc, we are having treatment 3. Treatment 3, which was bentonite treatment, and phosphorus, we are having treatment 3 as well. So my conclusion is that wood ash and bentonite are effective binders for Prosopis juliflora leaves and pods at a ratio of 75% leaves and 25% pods for lactating dairy goats. Thank you.
Can I have a seat? Have a seat. Let's just go back. Okay. Thank you so much for keeping time. I will now go to Kuunya. ICT. Is Amayu in the room? Okay. Let's go to online first, and then you'll be next. Okay, I think we can see him. So, Mr. Kuhn,
Yes, please.
please go on. 5 minutes or 7.
Yeah, thank you very much. And good morning, ladies and gentlemen. I know in Kenya it is good afternoon. This is Kunya Ronald of the Institute of Land Use Engineering and Precision Farming Technology, University of Debrecen, Hungary. I'm presenting on the soil tests as a tool for monitoring soil variability in crop production. This is a bibliographic analysis. My presentation outline has introduction, objectives, methods, findings, conclusion, and then acknowledgement. We know that soil is made up of a number of physical, chemical, and biological attributes, and the properties significantly impact the productivity of crops. So these properties vary by geographical location, climate, management practices, among others. That variation is in line with a lack of soil property consistency, which requires and up-to-date monitoring through two main things, and that is soil tests and evidence of scholarly work to that effect. So it is important to understand the latest focus on research in as far as soil variability monitoring is concerned. There are two objectives. One is to identify the latest research focus on soil tests as a tool for monitoring soil variability globally, and two, to assess the scope of soil tests that justifies its importance in the production of crops. We used some methods, and that was straight away, since it was bibliographic analysis, straight away searching of literature in Scopus database, and we covered the year range of 2020 to 2023. So we exported the data after the search and then analyzed the exported data using both viewer software. We came up with a number of 815 documents which were retrieved, and they comprised of research, review, and conference articles, including the books. So we came up with a search query, and that one could not go below 2019, since we were interested in having the latest focus on soil monitoring using the soil tests.
Kunya,
Yes, please.
there's a problem with the slides.
Oh, sorry.
Can you share?
So I'm on methods now.
Can you share from
Yeah,
your
next,
screen?
Next. You can now put next.
Can you share from your screen?
Okay.
From your laptop?
It's okay, it's okay.
Please.
Let me share.
You have stopped.
Can you go to the next one as we sort?
Don't finish.
I'm confused. So bear with technology. We are on it.
It's okay, it's okay.
Close the entire window. Seem to share.
Can you go to the next presenter as we sort it?
Just
It's sharing. It's patience.
Is it okay? Are you there now?
Yes.
So I'm on methods.
Okay, Kunya,
Yes, please.
can you start?
I'm there now.
Can you
That's
start?
where I am.
Can you start afresh?
Oh, that is very good. So that is my presentation outline. Soil is made up of a number of physical, chemical, and biological attributes, and those properties significantly impact the productivity of crops. These properties vary by geographical location, climate, management practices, among other factors. So that photo is a variation. So the lack of soil property consistency requires constant and up-to-date monitoring through 1, soil tests, and 2, evidence of scholarly work to that effect. So it is paramount to understand the latest focus of research on soil variability monitoring. We had 2 objectives. Number 1, to identify the latest research focus on soil tests as tool for monitoring soil variability globally, and 2, to assess the scope of soil tests that justifies its importance in the production of crops. This is how we handled it. We did the searching of literature in Scopus database, that software, and we considered the year range of 2020 to 2023. So after that, we exported the data after the search, and then we analyzed the exported data using Voice Viewer software. We came up with a number of 815 documents which were retrieved, and they comprised of research, review, conference articles, and books. So that one is the search query which was created, and we ensured that our search do not go below 2019. That one is a summary of the methods we illustrating Scopus database, Voice Viewer, data exportation. So we zeroed on literature research, and then the retrieval gave us 815 documents, which comprised of the items which are circled by that red. After analysis, these are the findings. Concerning objective number 1, which is identifying the latest research focus on soil tests as a tool for monitoring soil variability, we found out that there were increased investigations in soil variability monitoring, that all countries were involved in the monitoring of soil variability. So after analyzing the documents, we used the Excel and drew that graph. So we can see that all continents are represented. India, Asia, United States, that is North America, Australia standing on its own, United Kingdom, Germany representing Europe, Brazil representing South America, and so on. So specifically, we were interested in African countries in a special way to see whether they were also involved in soil variability monitoring. And we realized that they were led by Ethiopia and Kenya. And that is the graph for African countries. You can see Ethiopia leading and then Kenya following. we found out that predicting the future soil property changes is done by remote sensing and machine learning. We also realized that identifying the monitoring process is being performed by certain soil testing processes using agricultural robots. Those white elements you are seeing in the cereal plantation and the robots that are doing soil testing. Objective number 2 of assessing the scope, we subjected it to the voice viewer map. And when you look at the voice viewer map provided, you can see soil testing taking a major focus. So all other elements of soil fertility, crops, nutrients like nitrogen, phosphorus, fertilizer application are connecting majorly to soil testing. That shows that it is important to test the soil globally. So there is a strong connection of the index keywords that existed on the voice viewer map as a pointer to the essence of the topic. Secondly, the author keywords on the voice viewer map were evidence of consistent soil tests. As per that map there, you can see soil fertility and soil testing taking bigger ovals, meaning they are important in as far as soil tests is concerned and the consequent monitoring. Thirdly, soil testing went as far as organizations globally based on the shared citations. As per that map there, you can see the United States Department of Agriculture taking a center stage, but also supported by other organizations. That one helped to justify to us the importance of soil tests in the monitoring of variability across the world. In conclusion, generally continuous soil nutrient monitoring is necessary to increase nutrient use and agronomic efficiencies. 2, to reduce environmental pollution. 3, to ensure sustainable use of soil resources for crop production. And therefore, it is recommended that countries develop mobile, precision, cost-effective, and user-friendly equipment for sustainable soil monitoring. In my acknowledgement, there are those research team members whom we work with, Mr. Kaisari Ochwa, Dr. Peter Zaji, Brian Semugenzi, Eva Hovarth, Alpar Ilis, Hoita Saba, Andros Thomas, and my supervisor, Dr. Peter Ragan, and also the Ministry of Education and Sports, the Republic of Uganda, where I hail from, and my mother institute, where I work, Rentang Farm Institute in Mbarara, the Stipendium Hungaricum, who are responsible for my scholarship in Hungary, and the Tempest Public Foundation that are managing the scholarship. I thank you for your attention.
Thank you very much. We now go to question session before we break for lunch. Do you have any reaction, online or physically? Just put up your hand and then we'll bring the mic to you. For the presenters.
Yes, thank you, Chair. I have one question for Nagiganda. She talked about incubation in agri-businesses in the universities, and she gave us very good information on the perception and the factors that influence student sustainability of the incubation centers or units in Africa. I was just keen to see whether there were examples of the incubation centers and the number of students in those universities, because I didn't see the rate of success or failure of those students in sustainably staying in the incubation centers until they get to have their businesses, because the objective was to incubate students to establish their own businesses. I didn't get it very clear whether there were comparative differences in the different universities she talked about, and whether there were any core differences, because she just talked about the perception of students, and even why students, she gave example of KU for status and some things. I think I would wish to see whether there were numbers specifically, number one, and number two, what were the infrastructural problems in the incubation centers that would affect the student behavior?
Prof, can I just cut you short a bit?
Yes.
We had already asked them questions. I don't know if she's still in the room, but you can note down. Maybe she can.
I've come in late, or sorry then. But those two questions, I think if she can address them, it will be good.
Yeah.
Thank you. I also have one. I have two for Oma. First of all, she was doing something on Prosopis jubiflora, and she was working on leaves and pods. Did you manage to separate the leaves and pods so that you see the effect of the leaves alone and the pods alone mixed with the bentomite? Then you went ahead and analyzed the contents of the milk, and yet you didn't analyze the contents of the minerals present in the leaves and pods. Why did you evade that particular part? Thank you.
Thank you. Last question. Okay, Prof. Doctor, you can go ahead.
Hello. I have a question for Kunya. He says they analyzed also the organizations that fund the research on soil testing and monitoring and soil viability. I was wondering, when you did the analysis of these organizations, is it related to those that are doing fertilizer production, or are they the marketers for the fertilizers and other soil improvement products? Thank you.
Thank you. Maybe the last one from behind. I saw a hand.
Yes, thank you. I'm Edna Chepkemoi from CHS. I have the question on the last presenter. I would like to know which soil properties that you are considering or you are testing in order to come up with the soil sensing, to obtain that objective of soil sensing. Yeah, thank you.
Okay. Mr. Kunya, did you get the questions? Are you online?
Yes, please, I got it.
Please go ahead.
Okay, this one was a bibliographic analysis. We wanted to find out the importance of soil tests in soil variability monitoring. So by coming up with organizations, we wanted to find out whether there are organizations that are supporting the same initiative. And that was our concern. Is it being supported by some reputable organizations? That's why we realized that the United States Department of Agriculture is at the center stage, supported by very many organizations. That one justifies its importance that the country should take up generously. Thank you.
Oma? Please come, just come here. So why did you separate leaves and pods?
Okay. Before coming up with the ratio that I used, I did all those tests, and I wish I could show you. It was part of a paper I had written previously, that's why I didn't include it here. But maybe I can show you over the lunch hour all those the tests I did. I did a lot of them. Yeah. So I've also been asked that I analyzed the minerals in milk, but not in leaves. And I want to say that I did. This is part of my thesis, and that part I did in my second objective. So it was not part of, this is my third objective. It was not part of this objective. Yeah. So.
Can we clap for all the presenters for the morning session? And I also want to thank Dr. Oyo for doing the rapporteuring. So now we'd like to break for a 30-minute break, so that we can refreshen ourselves, and then we come back after 30 minutes. That is around 2:45. Please, if you're able to come back, just come back. We listen to 2 other presenters for the morning session, or you can as well stay the whole day. We have other presentations in the afternoon for these sustainable and safe food systems. So you can pick the milk card. I think it is. Who has the milk cards? So maybe you go through this place, you collect your milk card, and in exactly 30 minutes, please be back so that you can listen to